Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list published on July 14, 2025, so about 2 weeks ago. This paper proposes a new way to handle video calls with an AI, one that can cut the required video bitrate by 50% with only a tiny drop in the AI's understanding. The paper is titled Chat with AI, the surprising turn of real-time video communication from human to AI, and its approach could make AI video chat feel much more natural and responsive. Alright, so to get started, this first figure shows the basic concept of what's called AI video chat. You have a person talking to their phone, sending video and audio across a network to a cloud-based AI. Now, this whole system relies on real-time communication, or RTC. That's the technology that powers things like video calls. The AI itself is a multimodal large language model, meaning it can understand video and audio, not just text. The biggest challenge, which the diagram highlights, is that network connection can be unstable, creating delays that make the AI feel less human. Building on that idea of network instability, this next chart shows exactly how transmission settings affect that delay. We're looking at frame latency, which is the delay in milliseconds, versus bitrate, or how much video data is sent per second. The different colored lines show what happens as packet loss, which is data getting dropped on the network, gets worse. Traditional video calls, shown in the gray area, aim for a high bitrate to get the best quality for human eyes. But the key insight here is that for an AI, we can operate in this new yellow region, significantly lowering the bitrate to reduce latency. So if we're operating in that low bitrate zone where packet loss is more of a risk, how do we prevent the AI from just stalling? This diagram illustrates a clever solution called loss-resilient adaptive frame rate. The idea is to send video frames more frequently than the AI actually needs them. So as you see here, when a packet is lost and frame 5 can't be decoded, the system doesn't wait for a retransmission. Instead, the multimodal large language model just discards it and uses a previous redundant frame, in this case frame 4. This simple shift avoids retransmission delays entirely. Okay, so to properly test how video quality impacts an AI's comprehension, the researchers first needed a way to measure it. This figure shows their solution, a pipeline for automatically building a new benchmark they call the Degraded Video Understanding Benchmark, or DVI-Bench. The process uses AIs to create tests for other AIs. It starts by generating a low-quality video, then has a multimodal large language model create quality-sensitive question-answer pairs. The key step is filtering. A question is only accepted if a second AI gets it right with the original video, but wrong with the degraded one. And this is where that new benchmark really shines. It lets us see the impact of their core technique, called context-aware video streaming. This chart plots AI accuracy against video bitrate. The bottom red line shows a standard approach. As you lower the bitrate, accuracy plummets. But the top blue line, their method, is a different story. They can cut the bitrate in half, from 800 down to 400 kilobits per second, and the AI's accuracy stays incredibly high, dropping only slightly from 0.93 to 0.87. It works by focusing the data on what's important for the conversation. So, to wrap up, the key takeaway here is that by rethinking video streaming for an AI audience, not a human one, we can make huge gains. The Artic framework drastically cuts down on data and latency, making AI video chat feel much more natural and responsive. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.